Blessings to you. My name is Nigel Daring. I'm the originator of the philosophy of Darinism or Darinism. Um, well, this particular philosophy is based on an analysis of Genesis chapters 1, 2, and 3. Also, my analysis of existence of reality, and I found that in breaking down Genesis chapters 1, 2, and 3, that it corroborates my view of reality, what it is I've come to understand, and so what's there in those pages seem to be, I claim to be an actual representation of existence. The philosophy of Darinism or Darinism, you can find it really spelled out in my book called Existence, God, Man, Society, and Nature, which you're seeing here in the background. You can find it on Amazon.com, and you can either type in the name of the book or you can type in my name. If you type in my name, you'll see 16 books, and that's one of my books. Okay, so that's that book. Anyway, so in this, I did a couple of presentations before, 3 presentations before. I really recommend that you check those out before you come to this presentation. All right, now in this presentation, I'm going to look at what I call the properties of movements. The properties of movements. And so we're going to do a we'll do some. Let's do some review of what we did, of what we claimed last time, so that we'll then launch into our current discussion. Well, by the previous to the last presentation, right, which I labeled Darinism 2, I said the basic unit of mass is heat. The basic unit of mass, that's heat. All mass can be broken down into heat units, or what I call energy units or mass units. Heat units, when they accumulate, they form larger masses. Okay, so that all the masses that we see that's around in the universe, large and small, it's basically made out of heat. Now, the last presentation I did, the presentation prior to this one, I said, well, we concluded that each unit has what I call these fields that are intrinsic to them. And these fields I call them movement fields. Gravity, electricity, and magnetism. These are movement fields. Why do I call them movement fields? Because they do impact other heat units, and they're what cause the motion of other masses. So they do impact other masses, and they cause motion of those masses. I also said, well, we don't just have intrinsic movements, we also have what's called extrinsic movements. Extrinsic movement fields also impact the heat units, they also impact masses. The thing with extrinsic movements is that they are not integrally associated with any unit of mass or any center of mass. Unlike the intrinsic movements, they have some center of mass that's responsible for them. Units, the heat units, and the larger masses of them respond to push and pull locally of the intrinsic and extrinsic movement fields. So the intrinsic fields, the extrinsic fields, right? Those movement fields impact the units, the energy units, and the larger masses, and they create pushes and pulls on those masses through local lines of action, or what we may call force. Now, let's take a look at what we can discern as properties of these movement fields, right? And we can discuss them so we can come to understand them some more. What are their properties, and also how they operate. Well, one thing we know, one thing we want to claim is summation. Movements can overlap in space, and when they overlap in space, regional overlap, that results in a summing of the movement. So 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 when those movement fields overlap and you get a summing of the movement, you also have resultant lines of actions, right? That act upon masses locally, and right, and so the resultant lines of actions come from the summing of the movements which are responsible, which are there, which overlap in space. All right. So movements can overlap in space. Now, at a very fundamental level, unit masses, heat units, they cannot overlap in space. Even units of different electrical charge, they're going to be attracted to each other, and if they contact each other, they won't overlap. Unit so And that needs to be established at that very basic level, unitary level of operation, that unit masses don't overlap. Because if it's going to exist in physical reality, right, that sometimes masses can't overlap, that's something that also has to exist at a unitary level. And so there is the unit mass that doesn't overlap. Okay? For it to exist at a grand scale, it also has to exist at its very unit level. Movements overlap, but the unit masses do not overlap. Now, you can have larger masses, right, that can overlap with each other and come together and mix, because there's spaces in between, and the very structure of the masses allows for that, but the very unit mass itself cannot overlap, and that concept needs to be established at the very outset. Now, internalization. Internalization is another aspect of movement, right? When you have masses accumulated, they don't extrude movement. They don't, it's not like they're just accumulated and there's no movement inside the accumulated mass itself. When a line of action, right, contacts an accumulated mass, a mass of multiple units, that line of action can be internalized either in part or in whole within the mass itself, right? Within that mass that's made up of multiple units, multiple energy units. So a line of action, which which may call a force, but a line of action that impacts an entity that's made up of multiple units, multiple heat units, that line of action can be internalized in part or in whole. Now, what we must with that, we also note that an individual heat unit, an individual mass unit, an individual energy unit cannot internalize a line of action. It is just that's our most basic unit. It does not internalize a line of action. Now, something else can happen. When a line of action that impacts a mass can be transferred to another mass, either in part or in whole. Now, when the transfer can occur to various masses. So line of action, it can be transferred wholly to different masses, right? The mass that receives it can transfer it to different masses, or it may internalize part of what it receives and transfer the rest. Okay? So transfer only occurs when a mass that has a line of action acting on it contacts another mass. That's when transfer can occur. Transfer to a new mass begins a new line of action. So when the original mass having a line of action acting on it gets in contact to another mass and it transfers some or part of the line of action acting on it, that transfer begins a new line of action, right? It may be less than the original line of action. The original line of action, because the original line of action, some of it could be internalized by the original mass. Some of it may be transferred to another mass. But for any kind of transfer to occur, contact must occur with some other mass. Okay? Line of action acting on some original mass can be transferred in part or in whole to another mass or other masses, right? But for that transfer to take place, that other mass or those other masses must make contact with the mass that's transferred, that's transferring the line of action acting on it. Reflection. A line of action can in whole or in part be reflected from a mass that it impacts. So a line of action hits a mass, that it might just be reflected, either all of it or some of it. Okay? So that's also one of the things that can happen when a local line of action from a movement field impacts a mass. That action can be reflected, and of course, it's reflected at an angle by which it hits, right? So whatever angle it hits, it's reflected off by the same angle. Okay. Now let's compare intrinsic and extrinsic movements. So we review that. Intrinsic movements have infinite properties. They're infinite. That means they extend out into infinity. Now, with that, we must know that even though they extend out to infinity, and they extend out to infinity from some center of mass, right? They broaden out into infinity. What happens is that they lessen in strength the further out they extend into infinity. The strength, the magnitude of their strength lessens further and further away. Okay, so they have that infinite property in terms of presence. The other thing to note is that they're infinitely replenished in exact strength. What I mean by that is, if you have a mass in an intrinsic field and the mass is being acted upon by a local line of action from that field, and the line of action has a certain magnitude, the field at that point is not depleted by that line of action acting on that mass, because if that mass moves away and another mass is placed in its position, it would experience the same magnitude line of action acting on it that impacted the previous mass. So what that means is that the intrinsic movements constantly replenish themselves. They're replenished. Whatever line of action, that means with gravity, for instance, if I take this pencil and I let go of it, it drops. Now, where I had it, there was gravity there acting on it, pulling it down. Now, if I take my keys and I put it here, the same amount of gravity that acted on the pencil is acting on the keys. And because the gravity that was acting on there was gravity acting on the pencil and was moving the pencil, it was not removed. The strength of it was not lost from this point in space where I had it. It's actually replenished right there. So intrinsic movements have this infinite property to them. The fields are infinite in presence, in potential presence, in their range, and they're infinitely replenished at any given point. All right, so that's that. Now, an extrinsic movement field, however, is a finite field, and it has a finite dimension at any given moment in space. All right, so unlike intrinsic movement fields that extend to infinity, extrinsic movement fields have a finite dimension. With that, we must know that intrinsic movement fields, they're potential fields, right? So, and extrinsic movement fields are actually physical presences. Now, so gravity, for instance, or the electrical field, right? The field of a charged particle, the electric field of a charged particle, those are potential, and they only come into existence once there is a mass upon which to act. So they're always potential fields. They're not actual physical presences. Extrinsic movements like light is actually a physical presence. It's there. It's massless, but it's there as a field. All right. Now, intrinsic movements tend towards static, stable arrangements of masses. That means if we only had intrinsic movements, if we only had electricity, gravity, and magnetism, right? What would happen is, and we have only that in existence, all masses in existence would just come together in some sort of preferred static arrangement. But with extrinsic movements, however, extrinsic movements have the opposite effect. They have the scattering, randomizing dynamic effect on masses. Okay, so if you have a clump mass, an extrinsic movement impacting that mass would tend to scatter it. If it has a necessary strength, it'll scatter it. Okay, so it does have this scattering, randomizing effect. tends towards increasing entropy. That's what extrinsic movements do. All right. Now, the summation of extrinsic movements come from overlap of an extrinsic movement field onto itself. So so we said that extrinsic movements can overlap themselves. So if we have we're shining a light, we can also shine another light right where we're shining the light, and we can shine as many lights as possible right there. And it just where we're shining all the light, it just becomes brighter and stronger. And the light can overlap. What's happening is that the extrinsic movement field of light is overlapping it onto itself, and so it becomes strengthened. And that's how summation occurs in extrinsic movements. Is that there's overlap? It overlaps onto itself. With intrinsic movement, the summation of intrinsic movements constitute overlapping movements in regions of space caused by multiple centers of masses. All right. So the sun, for instance, that generates a field of gravity. That field of gravity that the sun has is not going to overlap onto itself, right? But the gravity that the Earth expresses would overlap on the with the gravity of the sun. Okay. Now, so intrinsic movements come from their summation actually comes from overlap from different centers of masses that overlap in space. Okay? An intrinsic line of action impacting a mass becomes an extrinsic line of action in transfer. What do I mean by that? Okay, so let's say I'm dropping this pencil. When I drop it, right? Now, I'm going to drop it onto my hand. Now, gravity is pulling down this pencil. There's a line of action of gravity acting on the pencil to drop it in my hand, but my hand blocked it. There's still gravity on it. What happened to the gravity that was pulling down on it? It transferred to my hand. Now, if I had something in my hand, maybe like a marble, and I had another heavier object that I dropped, right? Gravity acting on it, and I dropped it, touched the marble in my hand. The marble might shift and push out of my hand. That's because the gravity, which is the intrinsic movement, shifted to an extrinsic movement that then pushed away what's in my hand. So intrinsic movement, a line of action of any intrinsic movement becomes, when it transfers, it becomes extrinsic. Now remember, when it transfers, even though it transfers and becomes extrinsic, the intrinsic field itself is not depleted by that transfer, because intrinsic fields have this infinite property to them where they're constantly replenished. So at the point where the gravity acting on the mass transfers to an extrinsic line of action, that the strength of the gravitational field is not depleted. It is replenished. It's infinitely replenished. We can talk about that later on, why that is. But let's talk about the effect of that property. If it's infinitely replenished, and it's infinite, and it can contribute to a line of action of an intrinsic movement, can always be replenished, but yet it can always contribute to an extrinsic line of action. It can always create an extrinsic line of action in transfer. What it means is that the extrinsic field is becoming is receiving lines of actions from the intrinsic fields, and that in itself is broadening the breadth of the extrinsic field. The extrinsic field just becomes larger and larger. Now that explains what's known as a dark energy in the universe. Why the universe keeps spreading, because the light field itself, the extrinsic field itself, is itself spreading, and so it spreads the whole dimensions of the universe by that spread. All right. Now, an intrinsic field moves according to the motion of the center of mass that produces it. That means the Earth produces a field of gravity. Wherever it is, that's where it acts as a center that produces that field around it. As it's circling, that field around it moves with it, right? The extrinsic field, however, is just a given field that's out there, that's just broad out there. It doesn't really move in any translational way per se, but what happens locally, it can overlap on itself to provide for summation, and also it broadens, it expands in response to the constant transfer of intrinsic movement to the extrinsic movement field. All right. Now, movements have magnitude and speed character. They have their own unique magnitude and speed character. We notice, for instance, that the electric field is, as a movement field, is way stronger than the gravitational field. Its magnitude is that stronger. Now, when we're speaking of speed character, we're not speaking necessarily in terms of the speed of the field of moving per se, but of its impact on a given unit, right? It produces speed, right? The speed of that unit, or speed of a given unit entity, whatever we want to call it, however amount of mass we want to determine that to be. It does the impact of different movement fields is going to be different from field to field. They have different magnitude, and the impact that they have in terms of producing speed of the given mass is different. All right. Now, each movement produces a line of action in a given direction which does not change unless there's transfer. So this, for instance, of pencil, there's gravity acting on it, right? And the gravity is pulling it straight down, and that line of action is just straight down. So the pencil is going to drop. It just drops straight down, right? Now, so that's it's just a straight line of action. It won't change. The only way it changes is unless there's transfer taking place, right? Now, that happens with gravity, also happens with the light. If light is impacting a mass, and locally that line of action is going to push the mass in one direction. It's just going to keep pushing it in one direction, and the only way for that direction to change is if there's contact with another mass. Now, a transferred line of action, right, takes place when masses contact, and the direction, now when the masses contact, when the transfer is taking place, right, it occurs at the angle that the contact is made. So if we have two masses, right, let's take this pen and pencil. Whatever angle the pencil is coming from, right, and it contacts a pen, it pushes it away at that angle, or what? So when you have masses, when you have a mass with a given line of action, right, on it, it won't. The line of action will keep pushing it or pulling it straight in a very straight way, just straight, and won't change its direction. The only way it changes its direction is if it contacts another mass that's at an angle to it, and when it contacts that mass, the transfer takes place. Now that transfer, of course, can be in part, or in whole. The whole line of action may be transferred, or some of it may be transferred, but the transfer takes place at the angle of contact. All right. Now, just so we note the universality of the movements and mass interaction, let's just make these clear. The interaction of mass and movement occurs in the same way from levels of existence involving unit masses to those involving more complex masses. So what is happening at the atomic level in terms of interaction between masses, between protons and neutrons and electrons, and a line of action, that's the same. That's the same thing that would happen at the cosmic level with lines of action acting on the sun, on the moon, on meteors or whatever. It's the same principles that are going to be involved. So the interaction of movement, mass and movement, occurs in the same way from all levels of existence, from the unit masses to greater masses, and that the interaction of movement and of mass and movement occurs in the same way anywhere in physical existence. That it's the same thing that's happening, right? The same processes that's happening. You're gonna have a line of action happening. It can be summed, right? It can be internalized. It can be transferred. It can be reflected. These things happen whether we're talking at the atomic level, the subatomic level, at the level of stars and galaxies. The same things are going to be happening. Now, just to close out on this note, motion and movement. I decided to call these fields not motion fields, right? The intrinsic fields and the extrinsic fields. I didn't call them motion fields. I call them movement fields. It's the impact of these fields that cause motion. Now, motion itself is relative. Motion is always relative, right? Me, me standing on the earth looking at the sun in the sky, I would say the sun is moving around the earth. If it were ever possible for me to stand on the sun and observe the earth, then I'd say the earth is moving around the sun. So motion is always relative, depending on where your position is. Movement, however, is absolute. Whatever magnitude of movement is acting on a mass, that's just an absolute value. That's just absolute values. It's not. It doesn't depend on any position of any particular person. In terms of viewing what the whole dynamic of movement acting on masses or lines of action acting on masses. Movement is just absolute. All right, so that gives us our absolute. Motion is relative, but movement is absolute. Okay, we'll close it out there today, and I hope you'll check out my next video, and we'll continue building until you see where I'm going in terms of analyzing Genesis chapters 1, 2, and 3. But it's important for you to grasp this this breakdown of existence. So so that when we come to Genesis chapters 1, 2, and 3, it'll become clear as to what's going on. All right. Anyway, take care. Goodbye. Thanks for checking me out. Bye-bye.